I'm Stott, I'm from Microsoft. I work in Developer Platform Evangelism group, so long title. I do have an awesome job title, so I'm an Academic Evangelist. So what does that actually mean? It means my role is speaking to you and the rest of the UK community about how you use our tools and software. So my remit is basically anything Microsoft, and it's to really engage with the academic community and make you use our tools more effectively. So I cover things like Kinect, Phone, Windows, Azure, any product, Surface, etc. So, I'm here really to give you an insight today into enabling learning with the Kinect device. So what I want to try and do is talk about the Kinect. So where did the Kinect come from? Whose idea was it? What the technology is behind the Kinect. We're going to then do some very interesting skeletal tracking demos. So these haven't been shown before. So I brought Kenji Kataga with myself from Microsoft Research, and he's actually got this source code fresh off a machine yesterday. And we're going to show you some of the new features of what Kinect can actually do. We'll then talk about natural user interfaces, looking at how the new it will change the way people react with machines. We'll then look at how using this technology can inspire and enable people, you as academics, but also the student community. And that's probably my biggest passion in my role is seeing your eyes light up when you see this technology, and then seeing the students' eyes light up and become more involved in the teaching and learning experience, and then either wanting to go on to be researchers or wanting to go on to be entrepreneurs or work in industry. Then we'll talk a bit about Microsoft Research, and then we'll finish with the question and answers. So, some facts about Kinect, as many as you... How many people own a Kinect, by the way? Okay, so not as many as I expected. So, wrong age group, I was talking to kids before. So, the Kinect is really a gaming device. That's what it was intended for. That's what it was released as. So if you wanted to buy a Kinect early in the year, there was no chance. Everywhere was sold out. So we actually sold more than 10 million units in the first 6 months, which is, an absolutely tremendous amount. And it made it the fastest selling consumer device ever made. So iPad, nowhere near it. So, the Kinect is a great device, but it's not a new thing, and everybody thinks it's so new. But it actually started, I don't know if anybody can actually read the date of this email. So the Xbox team had done a lot of work already, and they had a pretty good system. They were thinking, do we need a controller? No, let's think of the human. So they built a system back in 2007, which was the basis of Kinect, and basically you could identify a human form. And when I say identify human form, it was the perfect human form. And we all know what perfect human forms are if we go around the shops. So then they were looking at this and thinking, God, this is so difficult. How can we make this work? And there's a chap called Jamie Shotton who this emails to. And he was a Microsoft Research, and he was doing all this really snazzy research into identifying forms. And Jamie's team was going out and they were videoing sheep in the fields and planes and buildings. And he wrote this paper. And this paper basically had this algorithm in which you could figure out what was foreground, what was background, what was this, what was that based on, colour, texture, material. And it was a fantastic report. So this is a quick lunchtime email from the Xbox team saying, we've got this idea, we've been working on something, we've read your research paper, do you fancy giving us a hand? So that was back in 2008. So in 2008, the Xbox was conceived. An Xbox development team was actually developed within Microsoft Research. They appointed staff, and they started to work on this project. And the problem was they had a finite time for delivery, because the Xbox team had already promised it as a product. So the Microsoft Research guys were moving away and developed what's on the stage there. So I think what's really inspiring about that is that just from a single email, from one idea, from one person at a desk, he sends an email to somebody else in the organisation, and they build something that sells 10 million units. So let's look at the engineering of the Kinect. What is the actual Kinect? So the Kinect has got 3 cameras on it really. When you look at the unit, you think it looks like 3 cameras. There's a depth sensor, so that's basically infrared. So there's an infrared emitter that fires out infrared. There's an infrared camera that reads that infrared. There's then an actual RGB camera, so a colour camera. And then we've got a motorised tilt, so it can go up and down depending on where you put it in the room. And it's got a multi-array mics. It actually has 4 mics built into it, and some really clever technology that can do noise reduction, noise cancellation, so you can pick up different people's voices. It can then identify where they're positioned in the room. So what does all this look like? piece of plastic with a couple of chips in it, basically, you know, nothing special. But the idea was to make it as consumer-focused as possible. It doesn't look like a gadget. You know, a 6-year-old child, pick that up, plug it into their Xbox, and it's not scary. It's about making it consumer-friendly. So, looking at the actual hardware, you know, the way the Kinect works is it's firing out this infrared beam. So if you watch the video, you can see these infrared dots. At the moment, I'm probably covered in if somebody's got an infrared camera. And basically those dots are set at equal distances. So what that camera is doing is actually drawing a 3D map of this area now and drawing me in, and it's actually working out from the distance of those dots how far I'm away from this wall, how far I'm away from here, and then it's using the algorithmic formula that Jason developed to figure out if I'm a person, or I'm a dog, or I'm a child, or I'm a big person, and then it can actually render that. So what it's doing this algorithmic control, and it's basically creating this depth image. So it's producing me as a depth image. It's then looking at how the different body parts are structured and identifying those and saying, you know, this is my left hand, this is my right hand, this is my head, these are my bodies, and you can see it's doing that very intelligently. And it's doing it pixel by pixel, so it's saying, the formula actually says, you know, what is the closest pixel to this point? Is there anything there? Is there the closest pixel to this point? Once it's done that, it actually creates a human joint skeleton, so you can see the crosses, and that's where it thinks my hand is, my arm is, my elbow is, and then it draws a skeletal figure. So if anybody's played Kinect at home, you know, it's quite good. There's no configuration or collaboration. So with the Wii or with the Sony Move, you literally have to stand in a position, let the machine identify you, do a pose. With the Kinect, you can literally just walk up to it and immediately play. So very intelligent. They'll also recognise things in the room. So I don't know if anybody's played and they've had the children running around them and you carry on playing. So the camera actually knows who I am and it won't pick up any of the interference. So this is all interesting stuff, but it's how do we take it a little bit further. So, you know, we've created this really good tool. It's very much consumer focused. How can we move that into the educational setting? And this is where NUI really has a huge opportunity. So in terms of research, you know, think about the things in terms of disabilities. How can NUI help people with disabilities? If I've only got one arm, or I need to read sign language, how can NUI help? You know, it's very difficult to use a normal PC, even with all the accessibility tools turned on. So we really see NUI as the future, and we've done quite a lot of work in terms of that, in terms of the platforms that we're releasing. So we developed the Windows SDK, and the SDK is pure software, and this is software that you can put on your PC, which then interprets the data that is coming from the actual Kinect device. So in terms of the SDK, it allows you to do a number of different things. The key ones are it provides raw sensor data, so it allows you to say the infrared and the video streams and the audio streams and manipulate them on your PC. So from a research or a teaching perspective, that allows you to use a depth camera, so I could do video conferencing, I could do audio conferencing, I could do minute recording. I could set up an easy Kinect demo which basically put into an office suite, have the meeting, it records the meeting, it knows who's saying what, when, how many times I said it. It could then do voice recognition, so you know which skeletons actually speak at the same time, so if the lights went off in the room. Lots and lots of applications and lots of potential commercial applications for this. The benefit for all you in the room at the moment is the SDK is for you. It's for you as academics and it's for you as enthusiasts. So it's about you building things and then coming back to us and tell us what you've done. Because that's, you know, that's the biggest thing I want. Is I want involvement from you to tell me what you're doing with it, and then I can then help you to showcase that and get grants and research on it. The skeletal tracking one is very interesting. So at the moment there's about 1 million sample reference data into the database. And the way that's been constructed is by using cloud. So, you know, we've carried out all this research data and it would be impossible to process all those data of human body shapes. So we use the Azure cloud to actually produce those skeletal records. Now there's opportunities there in terms of research of looking at how we can produce different record sets with different skeletal structures. So think of animals, think of horse racing, you know, that's quite a good one. You know, there's lots and lots of opportunities. In terms of the audio capabilities, the device is amazing, you know. The actual input and output in terms of audio is unbelievable as a conferencing tool. So there's opportunities there. So, you know, the SDK is your doorway into that amazing platform, and, you know, it's there to be used, and we really do want you to use it. So what I'd like to do is introduce Kenji, and we'll do a quick demo for you of how the actual device works.
Oh yeah, it's on there, isn't it? Don't forget it. Hi, I'm Kenji. I used to be at Southampton, so who's from Southampton? Sue's there, yeah, hi, nice to meet you. Nice to see you again. So this demo is basically using the SDK. It's come off Toby Sharp's machine, so Toby Sharp was one of the Kinect team, got it off his machine yesterday. Only a few people in the world have seen this. So the SDK actually provides you the sort of three pictures over there. So this is the RGB webcam live feed, that's the depth camera feed over there. The skeletal tracking you get with the SDK. So if you download the SDK, plug in a Kinect, you get that, which is a skeletal representation. What's new is this shows you what's happening behind the scenes. So this is the code that runs inside an Xbox. Okay. What it does is each colour is a part of the body, and so it uses quite an interesting algorithm. You can download the paper, it's been published, got Best Paper Award actually at SIGGRAPH. And each, so you see right hand is blue, left hand is red. If I do that, it gets a bit confused, but generally it sort of does it. So they've written their own algorithms to do this, but you could actually, from the raw streams, do your own. So the Kinect with the SDK, for instance, doesn't do finger tracking. Okay? But there are some people who are taking the raw data streams and developing their own finger tracking algorithms. And so we're very interested to see what people can do with this. So it's just give you a real live example of what the SDK gives you. So if I go up to the camera, you can see it's going darker grey because I'm closer to the camera. It actually tracks 6 skeletons, and then you can tell it which 2 to do the skeletal tracking with. So just to give you a real feel for exactly what the SDK does. So I'll hand back.
Okay, so yeah, I think the most important thing, so some of the real kill demos I've seen recently is is sign language. So I was at the University of Surrey a few weeks ago, and then we do some sign language, and we actually use the Kinect, and they've developed some new algorithm data, which some new code they've developed. And it was literally doing sign language with a teleprompt type over the top. So it was reading the sign language and then teleprompting it, which, you know, is pretty cool stuff. And that took about 4 weeks using the Open SDK. So using our SDK, I think, you know, there is other SDKs out there. The big advantage of the Windows SDK is it's supported, number one. It will be refreshed and updated with any ideas that come from the community. And most importantly, there's documentation to go with that. So there's about 150 pages of documentation. So just to jump back to the deck. So I don't know if anybody, you know, one of the key things for me is about inspiring young minds. So has anybody heard of Abertay University in Scotland? So Abertay run this competition called Dare to be Digital. Dare to be Digital is a competition they run over summer vacation. It lasts for 9 weeks, and it's up to teams of 5 students get together and they build games. The team that wins goes into the BAFTA Awards to be recognised. So I want to show you quickly a game that was developed by 5 students from Abertay over the summer. They did this in 8.5 weeks using the Kinect, and then hopefully you'll see how much fun they have. So you can see from the game the idea is to move your arm and jump up and down. So this game was developed from the ground up. They developed the graphics, the sound, the animation, the idea of how to do the movement and the controls. And it was a great scream, to be honest. So, just to start that. So in terms of, you know, what we think is available, this is a video by Kinect Education. Kinect Education isn't associated to Microsoft, but what we want to try and show you is what they're doing at the moment. So this is a community hub for Kinect developers to show off. We also have a community hub on the Xbox called Coding for Fun as well. So perspective, you know, the technology's there, the information and resources there, and it's down to you as individuals to either empower your academics and your learners, or to actually come up with ideas yourself. I think, you know, we're at a stage now where technology is pretty much limitless, and this is, you know, it's a consumer device that costs £80. So yeah, it is amazing. So I just want to pass over to Kenji. You can talk about Microsoft Research Connections.
Thanks, Lee. So Microsoft Research Connections is part of Microsoft Research. It's actually run by a guy called Tony Hay, who some of you might know, who ran the UK Science Programme. And I'm part of that team, and I'm based in Cambridge. And this is our mission, basically, is to work with the community to try and enable you to do better research. Things like, you know, we're working on how to use search technology to provide more information about AIDS, for instance, to try and help with that. So research, but also with education. We have a very large Women in Science program, for instance. So we were involved working very closely with the Xbox team to try and get the Kinect capability available to the research community. A lot of people ask, is this going to be available for commercial use? So this SDK does not allow you to sell a product. However, there is a commercial SDK in the pipeline that will be coming out in a few months. So we'll keep you posted on that. But other things like academic search, which is essentially a sort of semantic scholarly communications platform, so you can look for publications and things, but it can link data. And other sort of tools, so we do some tools to help with the community. So chemistry add-in for Word, for instance, allows you to put chemical formula into Word, and you can do different representations, graphical, scientific. And Node Excel is another interesting thing, which is an Excel plugin that allows you to put in network data. So that's an example of the Twitter feed that's been put in and then graphed as a network there. So that's just one of the things that we do. And one of the things we decided to bring along, because we've got Kinect, which is a lot of fun, but this is another project we're just spinning up called Gadgeteer, which essentially allows you to build gadgets. I was going to say something else. And so we're demoing this outside. You can come and have a look at that. So this video has actually how to build a digital camera in about 5 to 10 minutes, plugging all the bits together. And this is a platform for learning, teaching, and also for research as well. So we're very excited about this. The hardware has just become available, so it's something we decided to bring along with the Kinect.
So this will launch on October the 15th.
Yeah.
It will be consumer available.
So yeah, so do come and talk to us on the stand.
And the final one
Yep.
is just our contact details and information about the services and portfolios that we offer. So I'm from Faculty Connection, and Kenji's my opposite in Microsoft Research Connection. So we run both faculty research, and the idea is that we can join those together to get research of the future, but also empower you as faculty and administrators and academics to use our products more effectively.
All right, thanks very much, and come and see us outside.
Thank you, guys.